The following is a selected video from videomathteacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try videomathteacher.com today. Let's solve the following equation. We're given 3 times x minus 2 plus 5 times x minus 1 equals 3 times 3 plus x. To solve this linear equation, we'll refer to our steps on the right. In our first step, we'll clear the equation of any fractions. In our problem, we do not have any fractions, so we'll move on to the second step. Our second step reads, use the distributive property to remove parentheses. So, we'll distribute 3 to x and to minus 2, we'll distribute 5 to x and to minus 1, and we'll distribute 3 to both 3 and plus x. So 3 times x is 3x, minus 3 times 2 is 6, plus 5 times x is 5x, minus 5 times 1 is 5, equals 3 times 3 is 9, plus 3 times x is 3x. In our third step, we'll combine like terms if necessary. On our left side, we see we have 3x's and 5x's. These will add together to become 8x's. We also have minus 6 and minus 5, which will combine to become minus 11, equals 9 plus 3x. For our fourth step, we'll undo the operations of addition and subtraction to get the expressions with variables on one side and the expressions with constants on the other. So we see that we have expressions with variables on both sides, such as 8x or 3x, and we have expressions with numbers or constants on both sides, such as negative 11 and positive 9. So our goal is to undo the operations of addition and subtraction to get expressions with variables on one side and expressions with constants or numbers on the other. To do this, we would like to move our 3x from the right side to our left side. And to undo this, since we're adding, we'll subtract a 3x from both sides of our equation. Simplifying, 8x's minus 3x's becomes 5x's, minus 11 equals 9. 3x minus 3x will become 0x's, which will cancel out, so we won't write any variables on our right. So we've now moved the expressions with variables to our left side. Similarly, we'd like to move the minus 11 to the other side of the equation. To accomplish this, we'll undo subtraction by adding an 11 to both sides of this equation. So our left side becomes 5x, minus 11 plus 11 will become 0, which will cancel out, so we won't write anything, equals 9 plus 11 becomes 20. Next, in our last step, we'll combine like terms, which we've done, and undo the operations of multiplication and division to isolate the variable. Our goal is to write simply x equals, not 5 times x equals. So we need to undo the operation of multiplying. So, since we're multiplying 5 times x, to undo this, the reverse operation would be to divide. And so we'll divide both sides of this equation by 5. 5 divided by itself will cancel to become 1x, which we'll write as a single x. And 20 divided by 5 becomes 4. So the solution to this equation is x equals 4. Let's check our work by plugging in our solution into our equation and verify that both sides will simplify to the same number using order of operations. So plugging in x equals 4 into our equation would look like 3 times the quantity of 4 minus 2 plus 5 times the quantity of 4 minus 1 is equal to 3 times the quantity of 3 plus 4. Using order of operations, we'll first simplify within each parentheses. So this becomes 3 times 4 minus 2 simplifies to 2, plus 5 times 4 minus 1 simplifies to 3, equals 3 times 3 plus 4 simplifies to 7. Next, using order of operations, we'll multiply each pair of numbers. So 3 times 2 becomes 6, plus 5 times 3 is 15, and 3 times 7 becomes 21. And finally, 6 plus 15 does become 21, which is exactly what the right side is. Since both sides simplify to the same exact value, 21, that does verify that x equals 4 is the solution to 3 times the quantity of x minus 2 plus 5 times the quantity of x minus 1 equals 3 times the quantity of 3 plus x. So x equals 4 is our solution.